So let's just start making some video. If you've been watching along with the live class, the live async class, we're kind of skipping the lecture part, and then we're going to jump into video, and then we'll come back to the lecture part. So if there's lots of questions you have, hopefully we answer that in the lecture. We'll figure that out. If you aren't already, go to RunComfy.com and log in. If you're using something else, we'll have to figure out how to get you on Framepack. But yeah, I want to just start by making this video. And the video we're going to work with today is a model called Framepack. It's very unique in the way that it works, and I'll talk about that in just a minute compared to other video models we're going to play with in the rest of this class. So it's kind of both like not really that much of an intro to like what we're going to be doing for the rest of the class, but it's also, I think it's a helpful comparison to what we will be doing starting next week, like using WAN and doing more text to video flows and seeing diffusion across the entire video process. Okay, before I dive into this, let's just go open the model, get it running, and then as it loads, I'll talk about what Framepack does and why it's different and interesting comparatively to other models. So if you aren't already, come to the Explore tab here on RunComfy. Sometimes when you open it, it loads here with your workflows. We're just going to use the default RunComfy Framepack workflow. So go to Explore, and then you want to come over here and click Generate Videos. Framepack came out, man, I don't know, 4 or 5 months ago now. And it's kind of already been forgotten, but I actually think it's really interesting and why I want to talk about it. So from here, just kind of scroll down. You can do a search if you want to, but I believe it's going to be, let's see, where is it? It's going to be this one here. So you'll see it's called Framepack. If you click on the little arrow here, you see you can hit Run Workflow, or you can go to Details. Let's first just go to Details. You'll see it's called Efficient Long Video Generation. There's a couple other things here. So updated for improved stability, uses Sage Attention for 30% faster generation. We'll talk about a lot of this stuff throughout class later. Stuff like optimization, faster speeds, those sort of things. But for now, the thing I want to look at is just Framepack enables you to create professional quality video up to 60 plus seconds at full 30 frames per second with consistent quality from start to finish. That's pretty amazing. We are going to find that almost every single other video model cannot do this value. You can't generate 60 plus seconds. It's too hard. Full 30 frames per second is also pretty rare. So this is kind of an interesting model. And again, it's one that I think was hot for like a minute and then kind of dropped for other tools. And I think it's worth revisiting, and I think it's worth talking about. And I think as a first AI video generation model, it's pretty cool and pretty simple. So let's go ahead and hit Run Workflow here. The other cool thing about Framepack is it doesn't require a massive GPU to actually work. Usually, if you were to try to create a minute-long video, you would need probably a 48 gigabyte VRAM machine. We'll talk about why that is compared to this model. But essentially, you would need to spend a lot of money for one of these things. And in my experience, sometimes like a minute-long video, depending on your settings, can take an hour to actually generate. So you would be spending this much for one 60-second video. With Framepack, much different. We only need the really small GPU. In fact, if you have a GPU at home that's like 12 or 10 or even 8 gigabytes, you could probably run this model on it, which makes it really powerful or really interesting for users who don't have access to 48 gigabyte GPU. So I'm going to go ahead and click on this. You'll see my pricing here is set up for the Pro plan. If you don't have Pro, you're going to be spending $1 an hour. It should take about an hour. I mean, I think playing with this tool for about an hour is probably good. So if you are using Pro, you'll save 20 cents. If you are not using Pro, you will spend $1. We'll go ahead and hit launch. I'm going to just set it for an hour. I think that's plenty of time. And then we'll go ahead and hit launch now. And set up your environment. Will always take about 3 to 5 minutes. Sometimes a little bit longer. Usually a little bit longer, especially video models. So while this runs, I want to talk a little bit about what Framepack is and why it's interesting and still worth playing with. If you were to Google search Framepack, you would find the GitHub page, and you might find their project page as well. This is made by, I believe, 2 students at Stanford University. And I think just these bullet points here kind of describe what is really interesting about this model. So diffuse thousands of frames at full 30 frames per second with a 13 billion parameter model. And this uses a 6 gigabyte laptop GPU. So again, very efficient. It works with a very low power GPU or a low VRAM GPU. And there's a 13 billion parameter model. We'll talk about parameter models when we talk about this week's lecture. But 13 billion parameters is pretty large. Now, you can't really compare this exactly to a video model because the way this model generates images as video is not the same as other video models generate things. So this isn't like the same 13 billion parameters you would see in something like WAN. This generates at 2.5 seconds per frame, or 1.5 seconds per frame using Tcache. That means this is pretty fast. We will see this is much, much faster than other models, which is kind of why I want to do it as the first one, just because it'll get us sort of up to speed, kind of see how it works. And then when we compare it to other models, we'll be like, oh, wow, that's actually really interesting, really fast. The most important thing to think about here is this is video diffusion, but works more like image diffusion. What that means, we'll cover this more in the lecture, is a traditional video model. If you, say, set it to be a 5-second video generation and you want to do that in 25 steps, what actually happens is it generates all 5 seconds at one step. Then it generates the next 5 seconds, or the next step of those 5 seconds in another step. This model does not work like that. This model works in that it's more like, for those of you who have taken previous class with me from 2019, 2020, this works like next frame prediction. This works by predicting every frame one at a time, rather than trying to generate the full video at the full sort of length of the video. So rather than trying to generate 5 seconds all at once, it generates 1 frame, 2 frame, 3 frame, 4 frame, 5 frame, until it hits 5 seconds. Now, if you play with next frame prediction models, you know there's some issues with that, which they do discuss in this paper. I probably won't go through the paper too much here, but if you do want to read it, I recommend reading it. That is what they call drift, meaning the further away you get from that very first frame, the less coherent the image is, or less coherent the video model is. So you can imagine, you say, here's a single image, make this person dance. And what the problem you would see there is, like, sure, the first couple seconds looks like they're dancing really well. Then maybe by second 5, second 10, second 15, they've really kind of lost the coherence of the body, or it doesn't look like it's good dancing, or it's blurry, like those sort of things. They have done some stuff to kind of solve that, which they call anti-drifting sampling. I will say it doesn't work as well as maybe future models that we're going to look at do, but the payoff here is that you can kind of generate an infinite length, and you can generate very, very long videos if you wanted to. Here are some samples. So this is a image to video model, meaning you must provide it a starting image and then a prompt. We'll cover more image to video tools in later weeks of this class. Just know for this, you need a single image and you need a text prompt. So you're going to want to say, take this fuzzy elephant and make him dance. So you'll see this here, here's a cause model, dancing, etc. One of the things I'm going to recommend we try to do is we can try to do one of these things, like just take an image and have it dance. But what happens with more abstract stuff? I would definitely recommend, if you're going to play with Framepack this week, try a couple of these that are maybe more photorealistic, or just, people, and then try something more abstract and see if you can describe it. And you will see it can do 5-second videos, or it can do full minute-long videos. And I imagine if we were to jump ahead here, I don't think it's going to let me jump ahead, we might see that as we get further and further out, the model maybe gets a little bit blurrier. It looks less like our initial frame here. And that's pretty common of models like this. In fact, if you remember my next frame prediction tools that I used 2020 or whatever, this is pretty damn good. Most of the tools I've used in the past by around a second or two have gotten very, very blurry, and really drifted far from the initial input. So overall, this is a really interesting model. I do think it's probably going to work better with people dancing, more photorealistic imagery, because that's kind of what it's been trained on. But I do think it's always worth trying to see, what happens if I give it something more experimental, something more abstract, something more interesting that is not purely just make this person dance in the middle of the scene. And I believe most of these samples, the first image, the initial image they're feeding through, well, maybe that's not the case of this one, look to be AI images as well. I bet one example we might also look at is maybe we'll download an image off the internet that is not an AI generated image. We might find that non-AI generated images do not work as well as an AI generated image. So before you even start Framepack, you might actually want to go to Midjourney or some other tool that you use. Just generate a single static image that you like, and then come back and we'll feed that in. Let's see if RunComfy is now up and running. It looks like it is. Cool. So we did a little bit of RunComfy discussion, or sort of Comfy UI discussion, but I do want to use this moment to also talk a little bit about the tools that are available in RunComfy. Whenever you open a tool for RunComfy the very first time, you'll often see this panel is open. And this does kind of cover your space a little bit in kind of an annoying way. So what I always recommend doing first here is clicking the right arrow. This is going to collapse this menu. One thing we will kind of look at maybe in a minute after we generate some videos is that this is sort of your file browser. Remember, RunComfy is sitting on the cloud, so we don't have access to those files, so there needs to be some way to sort of see the files. This is your file browser. Almost anything you generate is going to be saved in the Comfy UI folder. So if you double click here, and then you double click into the output folder, you'll see that I already have stuff here. That's because I'm on the Pro plan, and it saves all my outputs by default here. If this is your first time using RunComfy, you probably don't see anything here. Stuff will save here, and we'll talk about how to output them, make sure we have our folder path set up, that sort of thing. That's the only thing I kind of worry about right now for RunComfy and the UI there. So RunComfy kind of has this like their own UI that sits atop Comfy UI's UI. And sorry, I will often say RunComfy when I mean Comfy UI, or say Comfy UI when I mean RunComfy. We'll try to be clear about that. But it is something that I consistently screw up in my brain because they're so very similarly named. If you click this button here, you'll see it just collapses. You can reopen that panel by clicking on Assets, and it will reopen for you. At the top of the panel here is another RunComfy UI. So this is your account. You click on it, it pulls up your dashboard. I actually thought that would come as a dropdown. It's going to tell you what your workflow is you're running here. So this is Framepack wrapper. It tells you what GPU you're using. It tells you how long you have. You can change this. You click on this, and you can either decrease the amount of time or increase your amount of time. Most people usually increase the amount of time. Cloud save, which I will probably do more of than you will. So for example, I might make some changes to this workflow. I'll hit cloud save. That will save it to RunComfy, and then I can share that workflow with you directly. Probably won't do that much this week, but I imagine next week when we dive into like some bigger workflows and we want to make some modifications, we can do that there. Stop will stop your machine. When you stop your machine, you're no longer being charged. So I set this up to pay for an hour. So it's 80 cents on RunComfy with my Pro plan. That doesn't mean I immediately paid the 80 cents. If I were to hit stop now, I'd probably only pay like 3 or 4 cents. But if I let this run down all the way, it will turn off. I believe this auto stop setting is... No, you don't want to do this one. Sorry, this is a different one. So auto stop is if you basically run a process, you want to shut down your machine after that process runs. Basically, that's if you don't know how long a process is going to take, then you would run it. And when it stops that process, then your machine turns off, I believe, 60 seconds after. This is your countdown, which means that, I don't know, let's say that auto stop process, like you're going to run a process, it's going to take maybe 30 minutes. So you're going to walk away to get lunch or something. The auto stop process would turn that machine off after the end of that run. In this case, because auto stop is turned off, this is going to stop at 55 minutes. So you would have burnt 25 minutes, whatever there. I probably wouldn't mess with auto stop unless I really knew I was doing something that was going to take a long time. Like maybe you're generating a video for an hour and you like need to go sleep. Maybe then I would set up auto stop just to make sure like my video finished processing, but also I didn't get charged for all that time. That's maybe where you do it. Maybe we'll play with this more. I really don't use this very frequently. Restart Comfy, we probably won't do a lot of. This is if you update some settings, you update some models. Restart is a good way to load those models in. We'll probably do this in a different way. We'll talk about this more maybe next week or the week after when we start to actually like load in LoRa's and those sort of things. We can skip the log, we can skip models, and we can skip files. Files are if you want to upload files. There's sort of 2 ways to do it. You can upload it here, or you can upload it from the asset finder. But that's the top. So again, this is a RunComfy panel. So this top panel is RunComfy. This right-sided panel is also RunComfy. Everything within here is Comfy UI. So Comfy UI has their own thing where you can kind of save and export out workflows. You'll see your queue over here as you generate things. Refresh node definitions is the other way where if you upload a model or upload a LoRa or upload some images, you can get access by refreshing. So I don't know, the RunComfy UI, basically before Comfy UI updated their UI, some of this was a little bit more important, a little bit more helpful. Now it's not. The manager, we will cover the manager maybe in this class. I don't know, manager is kind of like, hopefully we won't need it as much for this class because we're mostly going to be using predefined workflows. This is where you would install new nodes, install new models, that sort of thing. A couple other things over here that we will maybe get to later in class. Okay, all that said, I just talked about the UI a little bit. Now I want to get into actually using Framepack. I haven't used Framepack in a minute because, as I mentioned, it's kind of an older model. Not that much older, but just enough that people have kind of stopped talking about or stopped using it. Anytime I look at a workflow like this, I try to decipher how this was built, right? I didn't build this workflow. I believe this is actually built by Kai J, who's a guy we'll definitely be talking about in this class because he's very cool and very important to all of these Comfy UI workflows. He built this workflow, and it's kind of clustered in a way that I maybe necessarily wouldn't normally build my workflows. But I happen to know that Framepack is a image to video model, meaning I know that there's got to be a place to upload our image. So I come over here and I see load image, the load image node. Sometimes it's helpful to just sort of like stretch out what you have here. So for example, pull this out and I can sort of see here are my image nodes that are kind of doing some stuff. So what's happening here? So there's clearly like a resize bucket going on. And then we're feeding that image into this. So what do we know we need to do with this model, right? So we know it's an image to video model. We haven't talked about image to video too much since the first week of class, but image to video models almost always require a starting input image and a text prompt. The sort of sneaky or annoying thing about most video models is video models still require a text prompt. Why do they require a text prompt? Because you need to tell it what to do. You need to tell it the motion that it wants to see. You need to tell it, what the style should be for the images, like those sort of things. So we will probably next week talk a little more about text prompting. What kind of text prompting do we need to do in video that is maybe different than we would do in image generation, those sort of things. We'll cover that a lot more. In this class, we're just going to keep this as is. So I happen to know that this green box here, which is the text encode, this is our prompt. So you can see here what the default example is this image of two people holding champagne flutes. And then the text prompt here for what we want to generate is two hands toasting with crystal champagne flutes at sunset. One hand wearing a black glove, the other with red nails. In the background, a city skyline with famous domed buildings and bridges illuminated by golden lights reflected on the water surface. Golden bubbles sparkle in the champagne. The camera focuses closely on the moment of the toast, then slowly pulls back to reveal the entire romantic cityscape. The water gently ripples, causing the reflections to dance as the light creates golden spots on the surface. The color palette is warm, dominated by gold and deep blue tones, creating an atmosphere of celebration and romance. So a couple interesting things here. You will see that this describes multiple different pieces of motion, right? It describes motion that is happening in the overall scene. It describes motion happening in the water. It's describing motion that is happening within the illustration, or sort of within the glass itself. And interesting, I didn't realize this person actually had a black glove on them. So I thought it was kind of trying to alter the image, but it actually is a person with a black glove here and a person with red nails here. So it kind of describes both the image you already see, but also the motion that should change. One thing to note about Framepack is because it is a next frame prediction model, you probably don't want to be changing too much of the output. Like this is meant for like sort of like statically motiony images, not like, I don't know, like you're going to do like a drone zoom shot or something, right? Like the problem with the drone zoom shot is it might over like a second completely change the image. And I'm not sure how well something like Framepack is going to handle that. Framepack is really about like take this image and kind of add some motion to it, but don't change the image too much. I think you can even see that with some of their examples, right? Someone dancing, they stay in frame and their body moves. So the image kind of guides the body movement or like what the body should look like, but it's not completely changing the scene. It's not someone is walking out and someone new is walking into that scene, because that probably wouldn't work so well with this model. Maybe it would. I don't know. It's worth experimenting with. I actually personally think more people should play with this model more. Kind of why I'm showing you guys to see what you can make with it. So overall, let's go ahead and just find a different image to work with, and let's try to play with something different. So we've kind of set this up here where what happens here is we have our image input. What I can tell is happening is it's resizing our image in a couple different ways. I know why this is kind of doing this. There's like it's using a model called Clip Vision, which I've talked about previously in other classes. Clip Vision kind of embeds the image into the latent space. So this includes both a text prompt, but also this Clip Vision, which is kind of like image prompting in some ways. So for image prompting, you usually need to crop your image down to 512 by 512 or something smaller than that. It's happening here. Yeah, crop. So what's happening is this image is being fed as the starting initial input, but it's also being fed to Clip as sort of a image prompting tool. So that's why we're kind of seeing, I believe, multiple different resizes here. Or interestingly enough, it's doing some kind of like resize down to a certain size and then find a nearest bucket size and then resize again. This is kind of a helpful thing to look at. So this tells you the get image size, tells you what the output from this image is. So what it's doing is it's kind of scaling this image down to like a relatively small size. So if you uploaded something like 2K or something, it's going to do it's going to resize it. Then it's going to find this like nearest bucket to kind of resize to a certain, within a certain proportion. And that's kind of how we end up with this 832 by 480. So it's going to take this and kind of resize within this bucket size. That means, this video model really shouldn't be generating stuff at 2K, 4K, or whatever. For most video models, you're going to want to do a single video output at a relatively like 720p, 480p. We'll talk about resolutions more in the lecture class as well. But generally, between 480p and 720p is generally a good size to generate video at, unless the model specifically says it does high-res stuff. So we'll generate at this size, and then we will, if we wanted to upscale from there, we could use a video upscaler like Topaz or other video upscalers. That gets fed into the Framepack sampler. So let's actually come back to Framepack sampler because I think it's more important to look at the models used. So for anyone that has never played with prompt modeling in open source tools like Comfy UI, this uses what is called clip, but is really like there are many clip models now. In this case, this is going to use two different clip models. It's going to use clip L, which is the OpenAI version, and it's going to use Lava Llama, which is like a newer, more open source version, probably from Facebook since it's Lava. We don't need to touch a lot of this stuff. This is kind of the nice thing about Comfy UI is like, if I wanted to get in here and try a different sampler or a different clip text encoder, it might work, might not. But for us, we can just kind of load it, play with it the first time by just touching a couple things, and if we want to dig in further, we could. VAEs, I don't know. I don't want to talk about VAEs in this class. We'll talk about this more later if you have questions about this. This is the auto encoder. It basically turns our samples into pixels, latent space into pixels. Torch, this isn't even turned on. It's not connected to anything, so I'm just going to delete that. And the big thing here is the Framepack model. So this version of Framepack is the FP8 version. This is the only one that loads with RunComfy's workflow, so we're going to leave it as is. There is a BF16 version. We'll probably talk about this more later next week or the week after about like FP8 versus BF16. FP8 is a smaller, compressed version of the model, which means it still generates good quality, but it's a little bit smaller, easier to load, a little bit faster to load, and will still generate relatively good samples. This is like a whole discussion we're going to have like later in the next couple weeks because you want to work fast and then you want to work at high quality. So how do you sort of balance those two out? This is one way. This will run a little bit faster, but it does have a slight degradation in quality. And this model we can't really change, or we could change it. We have to go download the models. Not worth it. So go ahead and use this one as is. And then we come down here to Framepack sampler. The sampler node is pretty much always going to be the node that we're going to make the most changes to outside of the image input and the text input. This is where we can kind of tweak settings a little bit. The one thing I noticed in looking at this is it was a little bit hard to decipher. If you look at where this plugs into up here, it plugs into get image size and count. And you'll see that means the final image output is going to be 832 width, 480 height, and then what's called 145 count. That is how many frames it's going to generate. I was kind of looking around. I was like, where is 145 being set? 145 is being set actually here in the total second length. So it's converting seconds to frames, which is fine. But it was a little confusing for me to figure this out. So I think we'll start with just a 5-second generation, see where that goes, and then from there we will kind of add to that. So maybe we'll try one that's like 10 seconds, 20 seconds. We could go up to 60 seconds, but I don't know how long that generation is going to take. So I would start with just the defaults. So pretty much it's always a good idea to just start with the defaults. Make sure it runs as you expect it to. Make sure it's outputting things the way you expect it to, and then going from there. Last thing is this gets fed into the VHS combine node. This is the node we're going to see in pretty much every single workflow. This takes our frames that have been generated individually and converts them to a video, right? So if we feed it 145 frames at 30 frames per second, what does that actually end up being? That's 145 divided by 30. Yeah, about 5 seconds. So that's 4.8 seconds. So yeah, I'm not sure how it's converting from 5 to 145 back over to this. There might be some math going on behind the scenes that is a little off. So yeah, so I think at this point we're pretty much ready to run this. Again, for this class, I'm not going to go through every single node. We're not going to rebuild these because it's not really worth it. But if anyone does have questions about what each of these nodes does, I'm happy to talk about that more in the Slack channel. But for now, this is enough to get us started, right? So we know that we need to come over here and upload an image. So that'll be the first thing we do. Then we need to figure out our text node, and then we need to update our settings here if we want to, but I'm actually going to leave them exactly as is for now, run it once, see how it goes, and then maybe I'll extend it if I feel like it. All right, I'm going to go grab an image and figure out a text prompt for this, and I'll be back in a second. I'm back. I generated a image in Midjourney. I'm ready to upload it. So the way to upload images in RunComfy is to come over here, click Choose File to Upload, and then you can select your image. See, I just generated a person. Again, I'm going to start really basic. What I know should work with Framepack because of their examples. So a person, I'm just going to have this person dance with the city, with the bokeh in the background, that sort of thing. So you need to come up with a prompt for this. So again, we'll cover prompting in another class because I'm not the best person to prompt here. So we'll say black male dancer dances at nighttime in a city street. The man is wearing, let's just zoom in on this a little bit. The man is wearing a loose-fitting white sweatsuit that conforms to his body as he moves. The dance is urban hip-hop. God, that makes me sound so cringe. Dance is an urban hip-hop dance with sharp movements. Behind him, the city lights twinkle as the out-of-focus lights move slowly in a swirling bokeh. Okay, I have no idea if this is going to work, but I think this at least covers most of the basics. Let's see, is there anything else I want to say about this image? I can talk a little bit about the blue and pink lightings. Let's go ahead and maybe go do that. Let's add a little bit here. So he is lit with a soft pink light on his left and a soft blue light on his right. Okay, I think we have enough here to just work with this. Again, if I really cared, I would maybe get into prompting a little bit more, maybe use an LLM to help me prompt better, look into some stuff called JSON prompting. We'll cover more of that next week. But for now, we're kind of in a good spot here, at least to run this, assuming I can spell correctly. Okay, cool. So let's go ahead and hit Q. So the way to do this in this tool is down here. We'll hit the run button. Sorry, sometimes I push mine over to here, so I was like, where is the run button? So we'll just hit this once. Hit this once, it'll add it to our queue, and we'll see how long this takes. So I'm sort of tracking like 40 minutes left of my time here. Let's see how fast it runs. And we'll see this queued up here. And since this is the first time we're running this Comfy UI at this time, we should see, yep, we'll see that there is a green box that goes around whatever node is running at the moment. So the goal is that it runs every node from left to right. And when this one is running, that means we're almost near completion. Now, for Comfy UI, because this is the first time we're running stuff, these models have to be cached into the system. So generally, your first run, anytime you open up one of these in a brand new session, it will take a little bit of time to run. And by session, I mean like basically you haven't stopped the machine and restarted the machine. So restart is like a new session, and that means you're going to have to run this for a little bit. It'll be a little bit slower because you're caching all these models. The next time we run this, same way we either tweak our prompt, we change the length of the video, or we upload a different image and we change our prompt, like those sort of things. This will run much, much faster. Now, if we were to change our models, which you really can't do with this tool, I guess maybe we could change our VAE or we could change our text encoders. If we were to change those, there would be another sort of caching system on just those model changes. This is what's kind of nice about Comfy UI is that once you've run it in a session, it's much, much faster to run again. That's not always true of other tools out there. So in this case, it's going to be a little bit slow this time, and it'll be faster the next time. I can already see, we're making good progress here. We're at the sampler. So the sampler is kind of where a lot of this stuff is going to take a lot of time. It's actually going to generate each of these steps, and then from within there, it's going to output. Video saving should be fairly fast. We'll kind of see how this goes. Yeah, so we'll just kind of wait here. You'll see there's now a green bar here that's kind of showing us each step that it's generating. So we're generating 5 seconds. We're generating 145 frames, which is quite a lot. One of the things I'll mention now is, like, in general, you don't do 30 frames per second with most video tools. I guess you could, but a lot of video tools are designed to be run at 16 frames a second, 8 frames a second, 24 frames a second. There are some now that are 30, but in general, 30 frames a second is quite high, and often what you'll do is you'll do it at a lower frame rate and then double the frame rate using like an interpolation tool, which we'll cover later in class. So actually generating this many frames, this is pretty quick. And you'll see what it decided to do for the height. The buckets is 540 wide by 704 tall, so about 720p video. That's pretty fast. This is pretty amazing that we're able to do this with a relatively small GPU. A 16 gigabyte GPU is nowadays quite small. And you could actually run this on a 6 gigabyte GPU. So again, if you do have a local GPU, if you're running on a Windows or maybe a Linux, you can't really work with Comfy UI on Macs. It's just the way the GPU works is a little bit different. I know some people are kind of starting to do that, but it's still quite slow. So this is actually quite fast, although now our green bar reset. So I don't know what exactly is resetting there. Maybe it's just this is set to like 25 frames or something. So it looks like it's going to take a bit longer. Overall, a good experience. What we can also do is once this finishes, actually, I should have done beforehand. I didn't set my output path, which is a thing I always forget to do in RunComfy, and I end up with a very messy output. So let's just see what I can show you now where this is going to get saved to is you'll see here there is a file name prefix called 1217. What this is going to do is this is going to save this into my Comfy UI output, and it's going to create a file that is going to be 1217. So you can actually see how much I screw this up all the time. I have thousands of like loose files in here that all have these weird number prefixes. What I would recommend you do instead, let's actually do this and set this up now for the future videos we're going to run, is give this a name that is not just a numerical thing and give it something that makes sense. So like Framepack, and then let's go to slash. What this is going to do is this is going to create a folder in here called Framepack. And if I wanted to actually make this a little bit easier for me to find because I have thousands of files in here, let's do underscore Framepack. That'll put at the top. And then Framepack, and then we can say Framepack. Oh, this is where it always gets a little tricky here. Didn't save that. Great. Framepack / let's just do FP Dancer. This just gives me a little bit of like what is the name of this so I can remember what clip I'm using. So this will create a folder called /Framepack, and then this will create a file name of FP Dancer, and then it'll give it a unique postfix, sort of like a unique file name. Maybe it's like 001. I'll have to double check this. And that will give us a output generation that we can then actually go and find. It makes everything a little bit easier. For some reason, RunComfy by default often adds these indexes. I assume these are like numbers or whatever the like ID of the video of this workflow is. Which makes it kind of hard to find after. So this is a little bit safer. I should have also mentioned there are some other settings in here. So if you want the best quality video output, you could set this to like, I believe there's a ProRes setting. H.264 is going to be good. You can download it. You can load it into QuickTime. You can easily upload it somewhere else. It's kind of the default, but it is a little compressed. You can play with compression here by changing this value. 19 is actually pretty good. So you can make that lower if you wanted like 13 is like really high res quality. It's probably like overkill to be honest for a video like this. So 19 is probably good. Oh, and of course the thing that I always screw up with these the first time around these, we're not even going to save this video. It's just going to play here in this thing, in this video player because I didn't hit save output. I classic mistake that I always make the first time I run Comfy UI. For whatever reason, they always default to the VHS combine being off. I get why, because you might just want to preview stuff, but like it's always crazy to me that like they don't just turn that to save output. So anyway, now the save output is actually going to save. So it's not going to save this very first time. Sorry, I should have warned you. It's fine. We can just run it again. It'll be a little bit faster the next time we run it. And this will actually save out our video. One thing that did happen here, which is nice, is it did save out a metadata. So what that'll do is it's going to save out, we'll look at this in a second. It'll save out a PNG file. That PNG file will actually contain all of the parameters we used in this run. So we could rerun it again. And I'll probably show you how to do that I'll do it in this session. Why not? We're already spending an hour here in RunComfy just playing around. So I'll show you how to do this, but the nice thing is it'll generate a PNG. That PNG can then be uploaded and brought into other workflows to basically use these exact same settings. All right, where are we at here? Okay, cool. So we are now tiling our video. So this generated, and now we're tiling, and now we're actually generating our video. And here you go. Not bad. Does have a kind of hip hop dance to it. It got that right. You can definitely see if you zoom in, like how blurry those hands get. And I believe the reason that it's blurry, compared to say like the examples you saw here on Framepack. If we go to this project page again. You notice, no blurry hands here. Maybe it's moving a bit slower. I guess maybe that paw or the fin on the penguin is a little bit slow. One thing we're doing here, and again, this will get to more optimization kind of stuff in the future, is this is running a tool called Tcache. You'll see here that says use Tcache. This is turned on. Tcache is like an optimization technique, and it kind of speeds up the image generation process, the video generation process. But it has a pretty big effect on quality. I bet if I turn this off, and I might do this in later sessions, or maybe I'll do this over the week and share those examples in their Slack channel. When you turn this off, you'll get a slightly higher quality video. The downside is it's going to take a little bit longer. So that generation took us maybe 10 minutes. Is that right? Yeah, about 10 minutes, 8 minutes, which is still quite fast for a video of this resolution. I will say, like, it's still pretty fast. But there are some noticeable quality issues here. This is going to be a thing we see across the board with video generation, is especially around hands where there's a lot of fast motion. It gets very blurry. You'll see his feet, except for when his feet move, they stay pretty good. But his hands, which are serving constant movement, are constantly blurry. There's a couple reasons for that, right? In a traditional video, your hands might be blurry because they're kind of moving faster than the shutter can catch them. So there's a chance that the models just learn, like, hey, hands moving should be blurry. The other downside is just like it's an easy place to sort of drop some of that stuff, to compress. Like, these models are big compression models. They kind of simplify things. So it's probably a place where it just decided it's a little bit easier to draw. Hands are blurry. Again, we can try this without Tcache and see if it speeds things up. It's just how many times you want to generate the same video, right? It's worth it trying this again to see what you get. One last thing I want to mention here is, let's see what's in here for the seed. So seeds, we have not talked about seeds yet. Seed is, you can randomly generate this video over and over and over again. The seed controls sort of how random these things really are. So if I were to run this again, the exact same settings, I should get the exact same video output because my seed here is set to 47 and control after generate is set to fixed. Meaning every time I run this, it's going to run seed 47 of the randomization process. If I change this to any other number, let's say 48, or I change this to 0, or I change this to 10, this value will always lead to a different output video. Now, the output video might not really be that different because I'm using the same prompt. Maybe this model sort of like only knows one hip hop dance, so it kind of goes through the same steps. That's where it's a little tricky. We have to run this a couple times to sort of see how different this is. It's good that this is set to fixed in this case because it turned out I forgot to output the video. So now if I run this again, you'll find it actually skips all these steps because it's using the exact same thing. It says, I've already done this. I already know this. I've already saved these values into my cache. And now what it's going to do is actually going to save out this video file into this new location because I've edited this since I started running the first version. So if I come over here, go to Assets, and I go and I just scroll down. What was it? It was like 12:17. I don't know how long it's going to take me to find that. Let's go. 12, 12, 12, 17, 11. Oh, it should be here. It's not here. Maybe because I didn't hit save output. Even though I did hit save metadata, maybe it didn't save the output, which would be pretty annoying. Well, let's run this again. So what should happen now is if I run this again, I should get the Framepack FP Dancer. So let's run this again. You'll see it only did the video combine now. And I've still got pretty much the same dance, I believe. And if I scroll up here, scroll all the way back up. And can I refresh? There we go, Framepack. If I click in here, you'll see now I have a video file and a PNG file. Again, that PNG file can be used by, let's say I want to now run locally on my own Comfy UI local. I can download this PNG, drag it into Comfy UI, and it will load my current settings for my workflow, which is really great. You could also download this. You could stop your session, come back to your session, restart the session in a week, drag this PNG into your Comfy UI, and it would reload your exact same settings, and you can pick up where you left off. If you are not using Pro, if you've not signed up for RunComfy's Pro plan, you want to download these right now. So the way to download these is to click on one of these, and you want to come over, is it this one? Yeah, you want to go to download. And that's just going to download your file for you. So there's my file. There's my video playing. And you want to download this one as well, because you might want to reuse it. If you're paying for the Pro plan, the nice thing is these files will basically live on for as long as you've got them. That's why you see my output folder is a mess. If you are not on the Pro plan, you have 3 days to download these files, meaning if you come back in 2 days, these files are here for you. But after 3 days, they will disappear. That's just their way of sort of like being like, well, you're not paying for our tools, so we're going to quickly dump stuff as quickly as we can. So just know that if you're not paying for Pro, you do need to you pretty much do want to download your files in the session, or you'll forget about them and it'll disappear. Let's see. Okay, so let's figure out what else we want to do with this. So one thing we could do is I could turn off Tcache. Maybe let me do that. So I'm going to turn off Tcache. I'm going to stop the video, and then I'll restart the video with Tcache running, and we can see if the quality is any different. So remember, in this case, what I want to do to compare these one by one is I want to keep the C the exact same and only change one variable. This is kind of the process of sort of tweaking these numbers and seeing what you get out of them. If you only change and isolate one variable, then you can actually compare those quality differences to each other. If you were to say change the seed and change Tcache and change your prompt and change your input image and then you run it again, there's no way to compare one-to-one with each other about what is actually working and what isn't. So this week might be just kind of like try changing one value, seeing what the output is. Try changing one value, seeing what changes, those sort of things. The other thing that's kind of nice about Comfy UI is I can come over here and I can copy this node. Let's see, let's do this. Duplicate, 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 clone. So this is now sitting over here. This isn't connected to anything, meaning this video will continue to play as I go. This video will now update with my new settings. What this will allow me to do is, instead of having to download them, I can actually compare them side by side. And I'll even show you, once we do this, there's even a nice way to like sync your videos together so you can actually see them play next to each other. This is something you'll see me commonly do just as a way to sort of compare two videos to each other. Obviously, you've got like 5 seconds to kind of compare these things side by side. A better way would probably be to download the files, bring them into Premiere, scrub through them one by one, like mask one side of it, like sort of compare them more closely. But this is a nice down and dirty way to compare videos to each other. So I'm going to do this. I'm going to turn off Tcache. So Tcache is now off. I'm going to hit run again. You might not actually want to do this because I don't know how long it's going to take. I've got 24 here on my timer. So I'm just going to see how much longer this actually takes. So I'm going to stop the video. I'll come back when this is finished and we'll find out how much of a difference Tcache has on the output. Okay, so big reveal here. Tcache changes things quite dramatically. let me do one thing here real quick. So you'll see that my images have been uploaded, or my video has been output. I have on the left the non-Tcache version, and on the right the Tcache version. If I want to sync these videos, the way to do this is to right-click on this, and you can do Sync Preview. This sets the sync between these two videos to be the exact same length of time. And you'll see some really interesting things. So first off, the hands in the non-Tcache version do look much, much better. I mean, they still look a little gnarly when you actually like stop at a frame and look at them, but they are not nearly as blurry. The other thing you'll notice is like the motion is a little bit different at the very beginning here. They kind of sync up toward the end, which is cool, but they definitely do not match at the very beginning. I don't know why that is. It might have something to do with how Framepack works. It might have something to do with how Tcache works. I am using the exact same seed, so that kind of explains why they later sync up. But I think it's kind of fascinating. It's worth checking this out. I will say it maybe took another couple minutes to use Tcache. You'll see here I'm at like 11 minutes, so it was like, I think the first time I ran it took maybe 8 or 9 minutes, and that was with like caching all the models. And then Tcache took, I don't know, 12 minutes. So it added a little bit of time, but I would say the quality is much better. But what you can kind of see here is like, okay, maybe one thing you do is you could rough draft things in Tcache mode just to maybe be a little bit faster. And then when you kind of find the right motion, find the right seed, maybe then you would turn Tcache off, run it again, and then you could generate a little bit of a higher quality video. I'm not saying like, look, if I were to show this one on the right, I would probably be fine to show that. Like, obviously the hands are blurry, so if you're trying to trick people into believing it's not AI, then like, yeah, that's not going to trick people. I'm not saying this one on the left is going to do any better of a job of that. But I will say, you know, you can at least understand the motion, see if the motion you're getting is right with the prompts you're using, that sort of thing, that works. And then you can turn Tcache off when you want to get like maybe a little bit slightly higher quality version. So pretty interesting effect just by using Tcache on and Tcache off. This is something we're going to come across in every video tool we use, because Tcache is a very common technique to speed up operations, save a little bit of memory, other things. This will also be a thing where, like, look, we're using the FP8 version of our model. Where was that? I think it's here. Yeah, so this is the FP8 version of this model. There is, in the notes up here, there is a BF16 version of the model. That would likely lead to even a little bit better quality model output. The downside there is, again, it's going to be a much bigger model. It's going to be much slower to load. It will probably be a little bit slower to generate, but you've got options. So this is kind of a thing that we're going to see across the board, is that there's always ways to cut down on time, and often there'll be a trade-off for quality. And then on the flip side, there are ways to improve quality, but it will often require more time, higher memory usage, bigger model files, lots of this stuff. So for example, RunComfy RunComfy doesn't even support the BF16 model here. I'd have to custom download that and install it. You'll see Framepack only shows the FP8 version. I'd have to go get the BF16 version, upload it here. That would take a little bit of time because they're probably pretty massive files, and then running it again. So in this case, is kind of where RunComfy is a little bit of a limiter, but it also we were able to get started a little bit quicker than we could locally. So this is kind of the joy and the issues with both Comfy UI and RunComfy. So I definitely recommend please play around more with this. Like, try different images, try different videos. I'm going to do one more video for us. I'm going to do like an abstract thing. Like, I'll find an abstract image and try to animate that. And we'll probably see it kind of does stuff all over the place, but we'll kind of see. The biggest challenge is how to even describe abstract movement. Like, it's a whole challenge that I've struggled a lot with my own work. So we'll do that now. I'll stop the video again. I'll kind of change up the image and the prompt, and we'll run it again. Just because I don't want this video to be that long of a video. It's already pretty long. But I think I would love to see more people play with this. So try different images. Try different prompts. Try an image that with a prompt that doesn't really match it. See what happens. Try abstract stuff. Try realistic images. Try making an abstract thing dance. Different things you play with here, and it's all pretty simple, right? All you really need to do is set the two parameters of the image and the text prompt, and then maybe you would want to play with this, like maybe try during a 20-second video. See how bad it gets the further along we get. Try different things. that's kind of the point of this class. That's what I hope you'll do. So if you do make something interesting, I hope you'll share it in our Slack channel and tell people how you made it. You can always download the, let's see, how do I get this again? Output, Framepack, there it is. So you can always download the PNG, and if you want to share the PNG with people in the Slack channel, they can download the PNG and drag it into this here. So actually, let me show you how to do this. So I did download the other PNG. This was without Tcache, or this was using Tcache. So if I drag this just into the Comfy UI workflow, you'll see it changes. Now you'll see my other video disappeared. I only have one video here, and if I scroll in down here, you'll see that my use Tcache is turned on. That's as easy as it is. So you can download a bunch of these images yourself, maybe make a cool workflow, share it in the Slack channel. Someone else can grab yours and upload it and do the same. Now the thing that they won't have is your images, right? So if I were to share this with you guys, this would kind of show up as an empty blank. You would either need to ask me for the image or upload your own image, maybe change the prompt, that sort of thing. So it's not always perfect. It won't give you everything, but we'll at least show you how people made stuff. So maybe you changed some parameters in here, got different results. That might be interesting. It leads to different outputs, and we can then play with that as a group. Okay, last thing I'm going to do is I'm going to try an abstract image. So I'll be back in like 5 minutes, just with swapping out images and swapping out prompts. We'll try that one, and then we'll call it a day, and then you guys can go ahead and go wild with this tool. Okay, last example for the day. Let's do something abstract. So I made this image in titles. Shout out titles. You're going to hear me talk about titles nonstop in this class. Just because they pay my bills and I use them a lot and I think it's fun. We're going to download this sort of more abstract image. This was made using the Miyok Core model by Yalu. It's been a fun one. I've really been enjoying playing with it. It has this like weird 3D look with also these very like spindly sort of tendrily pieces. So I'm just going to download this. I'll just say Yalu. Configuration. And let's go ahead and upload that over here. And I need to come up with a prompt with this, so let me just say abstract 3D model with unique interior lighting. The tendrils of the shape float like being blown in a soft wind. Let's see what else we can do here. Maybe let's change the lights. Let's try the lights glow and pulse from inside the object. Much shorter prompt. I don't know if this is going to be worse or better. We'll just have to kind of see. And I will probably, I think the Tcache stuff was crazy enough. I'm going to turn it off. Just to see the results of like something with like a much nicer looking image like this. So yeah, I have no idea what this is going to look like. I have no idea how this is going to draw or morph. We'll kind of see how this model handles abstract stuff, and also like, to be honest, not the best of a prompt. So let's just run it and see. So I'm going to run this. I'm going to stop the recording just so you guys don't have to hang out while this renders, and I'll be back when it's finished. All right, well, spoiler alert, it kind of sucks, which is actually what I expected. Again, like, who knows what this data set was trained on? Probably trained on a lot of people dancing, which is why it's good at dancing. You'll see my output here is I'm not really getting a lot of glowing lights, not getting a lot of pulsing lights, definitely not getting any tendrils that are like blowing in the wind. And in fact, I get this sort of random 3D rotation that I didn't ask for. As we're going to find, this is pretty commonly what happens with abstract stuff. Maybe I could have written a better prompt to sort of say like the white tendrils undulate back and forth in the wind. I don't know. Like, I clearly could have done a little bit better job on the prompt, but I would have expected at least something that matched my prompts, and I didn't get any of that. And that's kind of the challenge of these tools is this a Framepack issue? Maybe, right? Like asking for glowing to pulse might be hard for it to do when it's only doing every image is during a different frame, right? It might not know how to pulse. Or it might just not have been trained on that, doesn't know how to do it. As we'll see, I love doing abstract stuff. I would much prefer to do abstract stuff than people. Most of these video models are not really great for that. And that's just going to be a challenge we're going to have to face. So this one didn't work out the way I expected it to, but I got good results using the other ones. So again, if you want dancers, this is a good model. I mean, all these models are good at dancing. That's just like the one thing they're trained on. They're trained on like thousands upon thousands of TikTok videos of people dancing. So if you want dancing, you're going to be set for life here. Maybe not the best motion, whatever. Maybe we'll look at that for vid to vid. If you want more abstract stuff, you might get challenges like this. Again, I could run this maybe 10 more times, and maybe one of them will be good. Maybe I'll do that this week. Who knows? We'll see. I did turn off T-cache, so no, it's not like a T-caching issue where it's kind of like skipping those sort of ideas, that sort of thing. So yeah, this one kind of failed. Maybe if I change the seed out, I'll get different ones that would work. But for now, I now know what I'm going to get with something like this with Framepack. Last thing I want to mention is I always forget like to do this the right way. You've kind of been hearing me eyeball or like try to guess how long something took by just looking at what changed in my counter. There is a actual way to figure out how long a generation took. If you come over here to the Q menu and you click on this, you'll see each of these has a time underneath it in seconds. So for example, my very first iteration of this took 432 seconds, and that was with T-cache on. My next one, skipping this one because this was just that video generation, this was with T-cache off, and you'll see it took almost 700 seconds. So almost, I mean, not double the time, but like 2/3 of the time. It took quite a long period of time to generate between these two. And this last one took even a little bit longer. So T-cache is definitely going to speed up our process. But as we saw, the quality trade-off is maybe not that great, especially if you want good-looking hands. So let's sort of keep that in mind as we generate stuff throughout this class. Obviously, I'm going to keep demos fairly short. I mean, this one's already pushing probably 45 minutes an hour. But you can sort of play with what you can get quality-wise and speed-wise, and we'll kind of keep that in mind as we go through class. Okay, so we have successfully played with Framepack. Again, I would love to see people just create a lot of more different stuff with this. Maybe try action scenes, maybe try romance scenes, maybe try scenes that are not just dancing. Maybe you can get an abstract thing to work the way I can't. Yeah, so just play with this tool. See what you can generate. I think it's pretty simple to use. You feed an image and you feed it a prompt, and it kind of goes off and does its own thing. Maybe you want to try to generate a full 60-second video. It will definitely take you a while. I don't know how much longer. Maybe an hour, maybe 30 minutes, something like that. Yeah, so try it. See how long it can go. See how long it goes before it starts to fall apart. Okay, that successfully wraps up this week of classes, although for those of you watching in the async class, we will do an actual lecture later this week. But for those of you who are watching after this class is over, you'll know that the lecture just happened, and now you get to watch this tutorial. Cool. So yeah, let me know what questions you have. This is a very, very basic step into video tools. Next week, we'll look at a lot more at how to do better prompting, something I did maybe terribly in this example, and being to dig into more tools that are more WAN-like, where they're doing different things than what Framepack does. All right, I hope this first week was enjoyable to you, and I'll see you next week.